authentication, security, data center, and networking. This is IT in the Bay.
She's cutting me off.
We got a little Friday the 13th coming in there.
That's how they do it to you. That's how they do it to you here at IT in the Bay.
Looking Point Studios.
Man, I'm so glad you're here today, Dom.
Me too.
You know why I'm here? I'm glad you're here.
Say that again in English.
You know why? How glad I am that. Do you know how glad I am that you're here?
I'm getting it. Oh yeah, I'm feeling it. Yeah.
Do you want to know how glad I am that you're here?
I'm feeling it. Yeah.
Okay. You want me to try it one more time?
I'm good.
All right.
No, then we can move on.
All right. Number one, back to IT in the Bay. Thanks for being here, Dom. I'm so glad you're here.
Glad to be back. Glad to be back. Glad to be here.
I even said it.
I'm glad you're glad. We can be glad together.
Let's be glad together.
Yeah.
All right. So we got a lot of comments around your ICE blog, which I think you know. Do you know how many views you get per week on your ICE blogs?
I look at it like 10 times a day.
Do you? Are you serious?
No.
I know you're kidding. Do you know?
I don't.
Take a guess. How many people read your blog, the ICE blog, a week?
I'm gonna say 20.
Keep going.
25.
Up.
2,000.
Come on now, not that many.
Okay.
I'll just tell you.
Okay, good.
So around 340-ish, 330-ish blogs. You're in a competition with Chris Marshall and his SD-WAN blog, but you're on top a lot. He's on top a lot. So I'm glad you're here to talk about it because I think people want to know more around the ICE blog series. So I was hoping maybe you could just talk us through maybe some of the 1, 2, 3.
Yeah.
How many? We got 3 or 4?
Jesus.
How many?
We've got like 9 or 10.
No.
Yeah.
Of the series?
Yeah.
Hold on. Yeah? Yeah. Jesus. Okay, sorry. Wow. I didn't realize that. That's great.
No, it's good to know you're paying attention. So I'm guessing that you are not one of those 340 like reads a week.
No, I totally.
That's not you.
Well, see, when I read it so many times.
Well, when you know everything, who needs to read a blog, right?
I think I read the first 3.
Okay.
But wait, you've written 10, 9.
There's like 9 or 10.
No wonder so many people read those things. That's amazing.
Yeah.
All right.
Do you think it was like one badass blog that people kept going back to
and people kept coming back to, but
okay. So those views then, is that an aggregate?
No, it's one blog. One of the blogs. I don't know.
Which one?
You guys just put general ICE, right?
No, it's per one.
It's just one blog?
Yeah, so it could just be
wait,
one.
Every one of mine gets 300.
Yeah. Could be.
Where do you guys get your numbers?
I never know what our marketing team is doing.
It's funny.
Anyway, so we're talking about a blog, the Looking Point blog to be specific, but this show is just in general IT in the Bay. But I think people love hearing about the ICE. So let's get into it. So ICE, you've done 9 of them now that we know that. I think that's one thing that's really important that I know.
Yeah. So ICE is can do a lot of things, right? And it can be a little intimidating to approach. So the idea with the blog series was to make ICE approachable.
Yeah.
Right. So we started out just talking about one of the core technologies involved in a network access control system such as ICE, which is 802.1x. So we had a blog that kind of went through and broke down for the reader what the different elements of the 802.1x architecture were, how they related to ICE.
Yeah.
A lot of people don't know that ICE is just one piece of 802.1x, right? You've got endpoints out there who run a piece of software called a supplicant. You've got the devices they're connecting to, your switches, your wireless controllers. Those are 802.1x authenticators. And then you have authentication servers. So this can be Microsoft NPS. It can be Cisco ISE. It can be Aruba ClearPass. This could any radius authentication server, right? That's where ICE sits in the 802.1x framework. The very first blog we went through walked through those components.
Okay.
And with some intention, right? Because when you're looking at deploying a solution like ICE, the first thing you want to do is get the things connecting to your network authenticating to your network.
What do you mean by that? Like,
so we're used to this with wireless. We don't even think about it with wireless. You know, you see the network, you click on it, and you get connected.
Yeah.
But authentication's built in to the wireless network. Every time you click on, our wireless network here, it's LP Corp, right?
Mm-hmm.
So every time you click on LP Corp, your computer is sending your credentials to the network to authenticate your access.
Okay.
Right? We don't carry that in our minds. We don't carry that same thought process over to our wired networks.
And
right?
I think because most people think inherently wireless could go everywhere outside of your building, and so people care more about that. But they think a wire is that's physical access to the network, physical proximity. But many conference rooms just have ports in them that are open. So so it's something to think about. But okay, cool.
Yeah, so I mean, it's the physical, security can work if you're a small company, you don't have many people, many strangers coming into your office. Yeah, I can feel good that my badge system to get me into the office, that's as much security as my network needs, right? From a wired perspective. But if you start to think about, I mean, even us here, right?
Yeah.
How many visitors come to the office here every day that you don't know about? Right?
Not that many, but yeah, some come, but yeah.
And so they come into our conference rooms, and we have network drops in our conference rooms. They could, in theory, pull out a cable and plug in there, just as easy as they could try to hop on our wireless network once they're in the conference room.
Right.
So one of the first steps that a lot of companies need to take when they deploy a network access control system is adding that same authentication framework that they've been using on their wireless network onto the wired network.
Got it.
That was kind of what that first blog walked us through, was that whole framework.
Do you think that that's a big paradigm shift for customers as they, is that the biggest step in this process, do you think?
I think that's the most heavy lifting they're going to have to do, because it does involve touching their endpoints and configuring them with the credentials that they need to send to the network to authenticate on the wired side.
Okay.
After you're over 802.1x, you can go anywhere from there with ISE, right? So you can go all the way to deploying a posture agent on these machines and checking for antivirus and firewall and registry keys. You can go berserk with host inspection, right? As far as you want to go. But I see a lot of customers, they're happy with being able to identify, just getting the information about all of the endpoints that are connecting to their network and authenticating those endpoints onto the network. That's kind of a first phase that I see a lot of customers take, so that they can gain some operational familiarity with ISE before they move forward.
So just the visibility aspect of it is enough for most customers.
Totally.
Cool.
Yeah.
Cool. And so that was phase one of the blog series.
Phase one.
Blog one.
One of three.
One of three, according to me. But you did a lot more work than that. I mean, not calling out exactly what was in 2 and 3 and 4, but as you progress, like the next series, what did you go after you get 802.1x deployed? Your machines are authenticating via 802.1x.
Well, we walked even more slowly through that process, right? So we just described what 802.1x was, first blog. Next blog, we talked about what kinds of authentication you can run between that endpoint and the network, right?
Okay.
So you can use usernames and passwords. You can use certificates. So we talked through the differences in configuration and the differences in the level of security that you're going to get between those two.
All right.
From there, we expanded on that. We actually showed the reader how to configure those supplicants, or what they're called, those little agents running on the endpoints that authenticate to the network. We walked them through how to configure those supplicants for username and password based authentication and certificate authentication. Then once we got that endpoint piece out of the way, we started taking a focus on ISE and what the policies look like on ISE and how we can leverage ISE to integrate with Active Directory. Now this endpoint's authenticating to us, sending us their user information. We can look that user up in AD. We can pull in attributes from AD. Most commonly, we pull in the Windows security groups that are already defined in AD. And we use those to differentiate levels of access between a domain computer and a domain user, for instance. A domain computer doesn't need access to your application servers. Your domain computer just needs access to the domain controller so that it can log in, essentially, right?
Yep.
Pull down its GPOs. So we dug into how you would configure role-based access control. In fact, we use that specific example, domain computer versus domain user versus domain admin, and we pushed down 3 different levels of access to that same port, depending on who was logging into it.
And when we say push down that permission, is that getting pushed down through a dynamic ACL? Is that what that's considered?
That's what we illustrated in the blog.
Okay.
Yeah.
And so essentially an ACL gets written and applied, or are the ACLs written on the switch in configuration and then you call those ACLs?
You can do that. That if in the blog series, I refer to that as kind of the legacy way to do it.
Yeah.
So now you provision the ACLs on the fly, right?
That's great.
So they're configured in ISE, right? So you define these downloadable ACLs. The great thing about it is when I need to change it, I change it on ISE, right?
Okay.
I don't need to jump around to my 300 access switches and update the ACL, use my Kiwi Cat tools, whatever it may be. I just update it on ISE. And at runtime, when the device connecting to that port authenticates, we match a policy on ISE. That policy says this downloadable ACL should be applied. The switch downloads that ACL and applies it to the session. When the session's done, the ACL gets trashed from the switch.
That's great. And so if
really great.
Do you know if every host that logs in, is it a separate downloadable ACL for each host, even if it's the same ACL, or does it?
It is.
Okay.
Yeah.
Okay.
Yeah.
Is there any memory concerns or anything like that?
There are.
Okay.
Yeah. I mean, there have always been memory concerns. So it is an ACL that lives on the switch when it's being applied, right?
Yeah,
So ACLs are written to TCAM, right? The ACE lines. Switches have a finite amount of TCAM space. It's becoming less and less of a problem as newer switch platforms are released. TCAM space, tends to grow, not shrink.
Yeah.
But one of the guiding principles would be, keep your downloadable ACL lines
efficient or
concise.
effective. Yeah. And so the ACL gets pushed down. So now you're providing security at the port level based on the user authentication. You can do that based on device type, right?
Yeah.
No,
that's right. Yeah.
Device type, location, who you are, where you are, what kind of device, anything else, OS.
When you are, right?
When you are.
So the time of day, right? We make networks closed at 5 p.m. Everybody, whatever it is. I don't think that's a policy many companies would put in place.
At least 6:30.
But it's possible. And then, so you touched on device profile. So what type of device? So that's another thing that ISE can do, is collect information from the network about your device, right? We look at your MAC address. We know who made the NIC of that based on looking at your MAC address, right? We can look at your DHCP request and we can see certain operating systems use certain options in DHCP requests. We can look at CDP information. ISE can collect all this information from the network to determine that I'm connecting to the network on a Mac OS X 10 computer, right? And I could write policy that says Mac OS X 10 computers get this downloadable ACL.
Okay, cool. And so it's really granular control, scalable, efficient, that kind of thing.
All those words.
Yep. And so regardless of technology, these access control systems essentially have this. Now the downloadable ACL, is that something that Cisco specifically has, or are other manufacturers, like HP, the others out there, how are they augmenting that piece of it?
So,
or do you know?
I don't know the full story, but I can tell you I do know that downloadable ACLs are not Cisco proprietary. Okay. Right. So your access switch has to support downloadable ACLs because the access switch is actually making a connection to receive this ACL, and then it's got to apply it to the port, right? So
got it.
The authentication server like ISE or like ClearPass or Counteract can send this ACL, and they do it in different ways, right? I've seen how it's done, for instance, on Counteract, and you write these one line at a time, like wizard things for your asynchries, so it can be cumbersome to put together. But in the end, they're sending the ACL down to the switch, and it's up to the switch to have the capability to understand that ACL coming back from the radius server and apply it to the port.
Got it.
And of course, all the Cisco switches are going to do that. And I don't really touch other access switches, so I don't know. I don't know the spread.
Yeah, I think we're talking specifically Cisco switches, so that's cool.
Yeah.
And so then now that you've gotten through the policy, we talked a lot about how you can make decisions.
Mm-hmm.
What other things in the like? What's where are we at? If we said, hey, in the blog series, are we kind of far along in the blog series, or are we kind of in the middle? Where are we at in the series when we're talking about downloadable ACLs?
I think we're probably more to the middle.
Okay.
Of the story than we're closer to the middle than to the end.
Yeah.
So we still haven't touched posturing in the blog series.
Okay.
We haven't touched passive ID. So there's a way to implement ISE without 802.1x.
Oh, okay.
Using passive ID for those customers who don't want to go through the trouble of provisioning the supplicant on their endpoints.
And so when you say supplicant, you mean authenticating the port with 802.1x?
I mean, when I say supplicant, I mean software, a service running on the endpoint's operating system.
Okay,
that provides credentials to the network.
That listens for that EAP start message. Is that what that is?
Oh, you talking EAP?
I don't know. I'm asking, man. I'm asking.
yeah. So the supplicant
EPOL.
Exactly. Exactly. The supplicant speaks EAP, and the switch speaks EAP, or the wireless AP speaks EAP back. They have an EAP conversation there that exchanges those credentials.
They EAPing.
They EAPing together, and then that switch or that WLC takes that EAPage and it turns it into radius and sends it off to the authentication server.
There's an EPOL. Is it a start message that the switch sends?
There's an EPOL start. So both the supplicant and the switch can send EPOL start messages.
Got it. So when you plug in EPOL start, and then there's some timers that come into play for DHCP and some of that stuff. So the authentication piece needs to be able to say corp or guest or whatever you have, right?
Yeah, ideally the authentication is happening quickly so that we open up that port so that the operating system's DHCP request gets through before it stops trying.
Got it.
Yeah.
Okay. And so we, on the blog series, where are you going to go? What's next for the blog series?
So I think we want to look at doing some TrustSec blogs. So far in the blog entry where we differentiated access using downloadable ACLs, we mentioned the fact that there was a newer, better, hipper, trendier way to do it now using group-based access control with security groups and security group ACLs.
Is that the SGT deal?
That's the SGT deal.
Okay.
Yeah. So the way that would work is when an endpoint authenticates to a network, same policy constructs that it goes through. We identify through our integration with Active Directory that you're a accounting user, for instance. We're going to tell the switch or the WLC that you connected through, this is an accounting user. Apply this tag to that user, right? And then anytime that user sends out a packet on a network, we're going to tag those packets with that group tag. It's a new metadata field, right, that we can put inside the data plane. So as they traverse the network, when they reach their point of egress, their destination, the switch that they're egressing through on the way to their server or whatnot reads that source group information from the data plane, and it looks at the port it's going to send that traffic out on, understands what group that destination port belongs to, and it had already pre-populated. I should back up on that one. So I kind of glanced over something here, and it's easier to whiteboard out than it is to talk about on a podcast.
Yeah.
So let's just talk about the concept first, and then we'll get into a packet flow. We assign groups to everything as they authenticate through ISE, right? And then we have a matrix. So this matrix, if you're going to envision it, is all the groups on the left, so on the column on the left, and then you have all the groups again on the row on top, right? And then you map, so you have these cells where they intersect, right? Source group to destination group. They intersect at a cell here on the matrix. I provision ACL, a security group ACL. It's a special kind of ACL because it's agnostic to IP addresses. All I'm saying is if you're from this group going to this group, I'm going to write an ACL that's layer 4 information.
Okay.
Right. I can also just say permit any or deny any, but I can get as specific as saying, permit TCP/80, deny anything else. So there's this security group ACL that exists in this matrix, right?
Mm-hmm.
So if I'm that switch and I had an endpoint connect, they authenticated, got assigned a group from ISE, I understand that I now have an endpoint on my switch with group 1, let's say. I know that I might be responsible for filtering traffic to group 1. So I'm going to talk to ISE and I'm going to download all the ACLs that could go to group 1, destination group 1. I'm going to have those pre-downloaded, right?
Mm-hmm.
So now when, let's say we have switch 2, device on group 2 over here sends a packet over to our original switch, that gets tagged in the data plane, that source tag. It arrives at that switch 1. So I've got source tag 2 in the data plane going out a port that's got destination tag 1 on it. I've already downloaded the ACL. I'm going to apply that ACL and drop or permit the packet.
Cool.
Was it?
No, that's really cool, because really what it does is it compartmentalizes access and makes it easy to segment access. So if you took a group and said, company A and company B, and you're running, maybe 2 companies out of the same network, or finance, accounting, sales, finance and accounting would probably be the same department, but
Probably.
whatever.
They know each other.
But you know what I'm saying. But sales, marketing, you maybe you want those guys together too.
Yeah.
I'm good at this. I'm good at combining and separating the same group. But so let's say you said sales and marketing, they're one group, and then you had finance and they're in another group, and then you got the sales database, account database.
Mm-hmm.
Sales could have access to that, and then maybe you have finance has access to the accounting system and the sales database. You could do that pretty easily with that little matrix deal.
Yeah, and this big deal about it is I'm pulling the IP addresses out of the equation.
Yeah.
Right. So it doesn't matter. I don't have to write these ACLs that are specific to sites any longer, because IP addresses are specific to locations, where these groups are not specific to locations.
And security group tag is a superior way of doing ACLs, it seems like, because then like you mentioned, subnets get really tricky if you're writing an ISE policy for users when they move around.
Mm-hmm.
And so you could easily write policies around going to servers, but going to, because the server IPs don't stay the same, but the source, I guess you would just say any destined to these server IPs allow or permit or deny.
Yeah.
So really you're getting into protecting resources, like protecting, protecting the server resources as opposed to protecting other assets. So as an example, if you have hosts out there, and maybe this isn't a great example, but maybe host-to-host communication shouldn't even be permitted in an organization. That would be kind of tough to do in a dynamic ACL that's globally provisioned for multiple sites, right? I mean,
that'd be really tough to do.
Yeah.
And maybe the use case is UDP's permitted host to host, right? Because we've got real time communication that.
Oh, I didn't even think about that.
But you know about that, and then so it gets kind of tough to filter. It's pretty much all UDP if you think about it, right?
Yeah.
It's like 30,000 ports, something like that. So you might as well just open up UDP between your user groups, but maybe they have no reason to have a TCP channel between them, right?
I love connectionless, connections.
Oh,
you know what I mean?
Yeah, I know. I know what you mean. Yeah, I've seen the video.
I don't need any windowing.
I know. I've seen your tech talk on that one.
Oh, thanks.
I think I've seen the black tapes tech talk on that one.
The one that we deleted. So all right. So you're gonna go. That's probably the next in the series is talking about security group tags. Probably using some of the newer switches, the 9K series, Cat 9Ks.
Yep.
Cool. Anything else on ISE that you're thinking that would be important, or any direction that you're thinking, like captive portal? What else?
Yes, I mean we haven't dug into any kind of web authentication that ISE can provide. We haven't got into guest access on the blogs. So ISE has a robust web authentication framework for guests, for BYOD. We haven't touched BYOD, so ISE can facilitate onboarding users' personal devices into the network, provisioning that supplicant for them that we talked about with the certificate, so that they can now authenticate, deploy a posture agent, assess the posture. We can integrate with MDM. We haven't talked about that, right? So if you want to, issue your users a corporate issued phone, or just say, hey, you can connect your phone to the network, but I want to make sure you register with, if you connect your phone to the network, you're going to register with my MDM product. So ISE can, since it's that authentication server, when that mobile device is getting on the network for the first time, we can recognize that it's not registered with MDM. We can redirect it through our web portal framework to register with the MDM product. The MDM product will, enforce its inspection policies on it, and then we can use metadata from the MDM product. So when in our ISE policy, so when a mobile device is connecting to the network, we can query the MDM and say, hey, is this device compliant with your policies? And it says no. All right, no, you're not on the network. It says yes. We're like, all right, you can come on.
Okay,
Welcome.
Welcome. Come on in. Well, I think it's been helpful for me to even get a little recap. As I'm an avid reader of the blog series, but I read the first 3. But no, I think it's good because when people are trying to tie this all together, reading the blogs, I think it helps to have some additional context, and they can get it in a little bite-sized chunk.
Yeah.
By listening in to the IT in the Bay.
It helps me to put it in bite-sized chunks too.
Well, yeah. Hey, well, thanks for stopping on by and chatting with us.
You're welcome.
Nice. I think our signature. You ready for this?
Okay, go ahead. Wait, what do we?
IT in the Bay, man.
That's our signature.
You listening to the podcast, or you not tuning in?
Oh yeah.
Here we go. IT in the Bay. We got the cheers. All right, thanks for listening. We'll see you on the next IT in the Bay. Peace out.
IT in the Bay. IT in the Bay.
In the Bay.
IT in the Bay. IT in the Bay.
In the Bay.
IT in the Bay. IT in the Bay.
In the Bay.
In the Bay.
Bay.
Bay.